Hello, on behalf of Sigma-HSE, thank you for joining us for our facility siding webinar today. We want to give everyone an opportunity to jump into the session, so we'll get started in about 2 minutes. Hello again, this is Mark on behalf of Sigma-HSE. Thank you for joining us today for our webinar on facility siding. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have about 10 years of process safety industry experience. That experience includes combustible dust, flammable vapor, and chemical reaction hazards, and steps to mitigate those hazards while in process. I enjoy getting the time to understand the pain points for our customers related to process safety. If we don't have the option to assist, I want to ensure we hand you off to a team we trust to bring value to your safety team. Please feel free to contact me should you ever need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world by providing actionable solutions to protect, enhance, and optimize their process. Our goal is to allow your team to focus on what really matters: protection for your people, business, workplace, and the environment. In this webinar, we will discuss facility siding, why and how to effectively perform your assessment. Facility siding is a key component of the process hazard analysis within PSM. This webinar will explore the latest methodologies available to help your organization meet compliance and enhance safety, from simpler approaches to more sophisticated techniques. We will have time for Q&A at the end of the session. Feel free to add questions to the questions section during the training, and we will address those at the end of our program. Vinny Simoes will be our process safety consultant leading our discussion today. Vinny, I'll turn it over to you.
Thanks so much, Mark. My name is Vinny Simoes. I have over 24 years of experience in process safety, including facility siding, incident investigation, hazards area classification, PHAs, auditing, anything you can think on the PSM arena. I've been exposed to and have been worked on helping clients achieve their goals in that. So the main objective of the presentation today is give you a little bit of an outline of facility siding, what is the relevance, incidents that led to things, led changes in our legislations to require this to be part of your assessment. Then we're going to go about facility siding, a little bit of introduction, the methodologies that are available out there, and basically focusing a lot on the methodology that Sigma-HSE applies to your customers. And then our final considerations, and as Mark stated, we're going to open for questions in the end. So what is the importance, right? Why do we need to do facility siting in a way, or why do we need to conduct those assessments and all, right? So it's important to understand what the fires, explosions, toxicity, and their effects bring to our community, to our employees, and etc. So with that in mind, we try to really protect is losses, and that being loss of life, loss of assets, and so far on. So that's what led us to start talking about doing siting studies and other things along those lines. So just a little bit of an overview of some of the accidents that happened in history. In June 2000, there was Mina Al Ahmadi in Kuwait, had a 508 million damage for an explosion that happened and over 5 fatalities in that accident. Also, if we look into another one in Algeria, was a LNG plant had a VCE happening. It was over 920 million damage and over 27 fatalities. For our approach here in the US, or the PSM OSHA requirement, what led to the change really in the legislation was in 2005, the BP Texas City refinery accident, which generated over 3 billion in damage and 15 fatalities. A lot of those fatalities come from that building that you're seeing over there, illustrated or in that picture. And that building actually was a portable building that was not supposed to be staying there permanently, and stayed. So what led to is a lot of evaluation, a lot of change in the regulation to say that we need to do the calculations and provide that the personnel inside the building is safer than the personnel outside. Because people would naturally think that because I have a shell protecting where I am more protected than if I'm outside. And in this case, not necessarily, because you can have projectiles, you can have ceiling tiles falling on you and so far on. So all of this is things that did that. Another thing that actually has been changing and have been leading to different changes in legislations as well, as for example, this accident in 2008 in Imperial Sugar facility in the US, where we have 14 fatalities from a dust explosion. So that led to change in the legislation for dust assessments too, which now you need to do a dust hazard analysis or a DHA, which is being similar to what we did in the OSHA legislation, the 29 CFR part 1910, which is requiring you to do facility siting, and PHA is part of that facility siting, or PHA and then facility is part of that requirement. So that changed it as well, and that's the first change that happened in the dust industry. So a little bit of introduction, right? So as I mentioned, since the BP Texas accident, OSHA 29 CFR Part 1910 119 requires a facility siting to be conducted every 5 years to be compliant with their PSM, or Process Safety Management Program. This is part inside the PHA, or Process Analysis section in that standard, and that's a requirement that we need to do. There's different ways to do it. The most notorious ways that people follow is API 752, 753, and 756 for occupied buildings, portable buildings, and tents and other things. So what we do is that as part of that requirement for PHA, we apply process hazard consequence analysis to estimate the severity. So we try to determine how bad that can be, and not determine in a qualitative way, which is what a PHA does. We determine in a qualitative way what accidents we can have, what risks we have, but we're now putting numbers. We're now quantifying that number and saying, okay, my building needs to be designed for that overpressure, for that radiation. So the problem that we have is that overpressure radiation toxicity will only tell you part of the story. So you need to evaluate also what's the response of the structure to that overpressure. Is that simple idea that if I hammer a wall with a little bit of strength, at one point that wall will fail. So it's the same kind of principle that we're going to do with the structure response, is understand that there's a pressure, the overpressure is only going to give me a little bit of impact, but if it's in a prolonged time, it can be worse, or it can be like a very short duration, but a very high overpressure that will damage that structure. So all of this is part of what the structure response analysis is being added to the API standard. So the methodology that a lot of people follow, and we in Sigma follow too, is the scenario definition. It can be like basically from plot plans, P&ID reviews, and other methodologies can be from hazards and so far on. We're gonna look into options. First one is lookup tables. This was the original API standard. We don't really use that anymore. We move into a consequence-based or a risk-based facility siting. So the consequence is basically what it's saying. I just look into how bad things can be. In the risk-based one, I include frequency and probabilities. So I look into frequency, probability of ignition, probability of wind distribution, probability of the wind blowing in that direction, probability of having personnel inside the building, and so far on. So that's where the difference becomes. So a simple facility siting process will go into scenario identification, consequence analysis. We do the structural assessment, and we'll talk a little bit later on what kind of structural assessment we're gonna do. And then, is the API criteria met? If it is, great. We're gonna push in a final report, and that's what it is. Let's say if it's not met, then you have the option to go into a quantitative risk assessment approach. So you put frequencies, probabilities, and so far on. And then we do the structural assessment, and then we ask ourselves again, is the API criteria met? If it is met, we push the final report out again. If it's not met, then we need to work on building retrofits. And we're going to talk about options like this, but it can be as simple as putting a shell around this building or really redesign a building completely. So we're going to start by talking a little bit about the consequence-based facility site, right? So that's the one that's mostly widely used in the US. There's a little bit of resistance sometimes, we can say that, in terms of acceptance of risk. That has a lot to do with laws, legislations, and other things along this nature. So we tend to stay a little bit more into the consequence and not accept the risk per se. So we do the hazard identification, we do our consequence analysis. Then we ask ourselves if that scenario is met, or if those scenarios that we model have like passed the criteria for API. If it doesn't pass the criteria, then in Sigma, what we do is we identify some key CFD scenarios. We do run the CFD scenarios, and we apply an effective mitigation, and we look if the criteria is met. What's the advantage about doing that is that we're running the CFD. We're gonna talk about later on how it's a simple approach to the CFD, and it can run in a very effective time and not affecting that much timing, budget, and so far on. So it's a sharpening the pencil that may give you the answer that you need. And we're going to do a case study with that and everything. So basically, as I mentioned, we're going to do our scenario definition for plot plan and PNID reviews. We're going to do a different approach depending on what the client requires. You can do a 3-hole sizes. We can do maximal credible event, which the maximal credible event is just an idea to say, for example, it's very unlikely that I'm going to have a guillotine failure on that pipe. So I don't want to design my facility to the worst case. So then we talk about the maximal credible event. That's going to say, okay, there's most credible event that we can have from this situation here is a 2-inch hole or is a 1.5-inch hole. So that's what the maximal credible event approach is. Or of course, a client specific requirement. The client may have specific requirements. You have 1, 2, and 6 inches. The client may have like that. I want to do a 1/2 inch and a 1-inch release, so whatever it is, the approach, it's what is going to be followed. Then we're going to look into radiation modeling, for example, 4 kilowatts, 12.5 kilowatts, and look into what the damage to the building will be. And if the building can withstand that. We look into also toxic modeling, which can be done by different ways, ERPG, IDLH, EGLES, and so far on. We look into overpressure, for example, look into how much overpressure can this building withstand, and we'll look into that impact as part of our assessment. So with that in mind, we're going to do a quick case study just to show you an idea. So basically, that's a little process area. We're going to have a hole on that where I'm highlighting, and we're going to look into the impact into this administration building, warehouse, and so far on, right? So we're going to apply a little comparison between an empirical model. There's several ones in the industry, but for this case, we chose FAST, and we're going to do this as well with a CFD package. So we just take a little bit of a model in terms of we use FAST for this approach. So we just look into what would be the volume of the cloud if I have a horizontal release with a 2F, which is a very stable condition. So let's say in the kind of night condition, and a 6D, which will be more of a day condition. What comes out of that is that you can see there with the CFD, we barely touch, with the half LFL, we barely touch the building, but with the empirical model, we're really covering the building with that cloud. In terms of flammable cloud, of volume of a flammable cloud, we're talking about the 2F, a 280 cubic meter cloud to an 88 with the CFD approach. And then in terms of the 60 stability, we're talking about 196 cubic meters to 100 cubic meters. So with that in hand, when we plot this as an explosion, we still use the empirical model for the explosion. We did look into, if I'm using the empirical model, both of the scenarios provide me overpressure reaching that building, a 2 psi overpressure reaching that administrative building, which that leads to me is that if I'm looking into plotting in against the P&I curve, it's going to tell me with a low, medium, high response, I'm going to look into what the impact will be. And what this will give me is that with a conventional approach, it will be a BDL or build damage level 4, which will be in the collapse range, occupant vulnerability of 0.838. And then in the hybrid, it's the one that we did with that, we got a medium BDL, and we got a much lower occupant vulnerability because we only reach 1.2 psi on that building. So when I'm looking into that kind of building down, like in this picture, it's just a regular, simple, very useful, very used around the US in terms of administration buildings. Is you can see what the impact will be in that kind of building. When we look into another factor, could be the fire modeling, the CFD will allow me to consider buoyancy of the jets, while the empirical models will not really consider the buoyancy of the jets. So you can see the difference, that I will be assuming that in the empirical model that this jet fire, as you can see the radiation profile over there, will be reaching the building, while if I'm doing a CFD, the volume of the equipment, the wind direction, the wind patterns, and all of this will allow me the buoyancy on the cloud, of the buoyancy of the jet, which in the end of the story, what this creates to me is that with the conventional approach, I will reach over 12.5 kilowatts into that administration building, while on the hybrid, I'll be less than 4 kilowatts. Again, we'll go back to that conversation about the conventional and the hybrid approach. So you can look into what the BDL of 4 creates with that 2 psi overpressure and the 12.5 radiation levels reaching there. While in the hybrid, we're reaching basically 1.2 psi and a 4 kilowatts or below 4 kilowatts. So what this creates for us in a nutshell is that we need to look into what the impact is. And for that, I'm gonna post a poll question for you guys, and I wanna get what would be your expectation. How much do you think this hybrid approach would reduce that that likelihood of, or that impact, right? So I'm gonna post 2 poll questions back to back. Sorry, guys. So the first one is what is your preferred method, or what methods you guys apply? Is it consequence-based, risk-based, or if it is lookup tables? I'm gonna give a couple minutes, and then we're gonna close this poll. All right, so we're gonna close this poll, and you guys are gonna see the results. So I'm guessing you guys can see the results, that it seems a very small percentage of you guys use the lookup tables. The majority use the risk-based, and about half of the people use consequence-based. We have a wide range of attendees, and people from Europe, people from different areas, and people from the US and the Americas for all that reason. So we can see that major thing. Then I want to I'm gonna post a second poll for you guys. And what kind of reduction do you guys expect to see from this change? So do you think the reduction is going to be from 500,000 to 5,000, from 500,000 to 10,000, or from 500,000 to 50,000? That's just for this example. Of course, we're going to talk about this later. Or do you think it's going to be no significant reduction? The same idea. I'm going to leave a couple minutes for you guys, and then we're going to get to answer that question. All right, so closing the poll. So the majority of you guys are thinking that it's going to be between 500,000 and 50,000. 70% of you guys think there's not a significant reduction. And then the real answer for this is that it can be in a range. It's usually in this case, it was a 2 orders of magnitude that we're talking about. We're talking about a $500,000 to 5 million range for the conventional, and that could be like just do a shell. As I mentioned, we could do a shell around the building that will fit, that will withstand the overpressure and thermal radiation, or we do a whole redesign of the building and decide that as a blast and fire resistant building, which will be the highest end of that cost. Once we talk to the hybrid approach, all we need to do is reinforce the glass, or basically reinforce glass doors and frames to be resistant. So in all reality, it was the smallest percentage of people get this right. But again, it could be 50 to 50,000 and 50 to 10,000. It will depend on how much we need to do. But for this one, we got to the highest range of it. So that's great. We got to that answer. We answer ourselves the question. We got the information. But let's say that this failed. This still gives not enough result, and we still have an issue. We can move forward with the risk-based facility siting, which in addition to what we did, we're gonna start adding frequencies and probabilities. So in all reality, what we're gonna do is this extra step here on the quantitative risk analysis, which we're gonna add the frequency calculation. We're gonna add the regular probabilities that we're talking about: probability of jet fire over an explosion, probability of an ignition, probability of the population being present, and then we're gonna sum this with a risk calculation. We're gonna present this in an individual risk per annum, or IRPA. We're gonna present as a FN curve, or frequency number of fatalities curve. We can do this in individual risk contours, and we can do this exceedance curves and exceeded contours, which tends to be how we're gonna do most of the evaluation on the facility side of things. So with that in hand, what we're gonna do is we're gonna do very similar. We're gonna do the scenario definition for plot plans and PNID reviews. So it can be like I mark it up a PNID, define what my events are, and then modeling those events from that situation. Then with that, I'm gonna do 3 hole sizes, be 3, 4 hole sizes. It will be an approach that we usually do on quantitative risk assessments, that we don't do just a single hole size. We do a range of hole sizes, and we can do different probabilities for the different hole size. So it can be like, for example, 1/2 inch, 2 inches, 6 inches. Then we come up with what the radiation modeling is going to look like, and then we define our exceedance contours, as you can see. So I have like a 4 kilowatts per meter square being exceeding at 110 to the minus 3, 110 to the minus 4, and 110 to the minus 5, and you can see what the range of results will be. I can do the same for my toxic modeling. So I look into what will be the probate contours, and I look into what the impact will be. And I can do the same for my overpressure contours. So I look into what the chance of exceeding a half a pound, 1 pound, 1.5 pound, 2.5 pounds, and 3.7 pounds is going to be when I combine all those scenarios together. With that in hand, I also do specific exceedance curves for the buildings of concern. So every occupied building will have their own exceedance curve, and we can look into the probability of exceeding a certain side-on overpressure on that building. That helps me to determine what's the impact will be for that. With that in hand, I also will provide you, or also is provide a table with what the impulse and overpressure is for those buildings. So you can see, for example, if I have people in the maintenance workshop and my threshold for acceptance of the risk is 10 to the minus 6 or once every million years, I'll have a 1.72 psi on that building and a 44 psi per millisecond impact on that building. So I need to start looking into what will be the impact there. If I take the main control building, right, then I need to look into what the impact will be, because, for example, now I have a 3.6 psi overpressure, which basically means that regular buildings will not withstand. I'll need to do a explosion proof building so I can actually get this design accordingly. So that helps me define what it is, the impact. And what do we do in terms of structure response, right? As I mentioned, 752 and 753 now require structural analysis as part of it. Those are the standards that we mostly are guided by facility design in the US. P&I curves, we define P&I curves or pressure and impulse curves for preliminary building analysis. And then if they fail, we can do further analysis. We can do finite element analysis for building response, and we can even go into a full-blown building retrofit for this. So with that in hand, what I do is once we define this P&I curves, like this one in the here, we plot the value that we found in that curve, and we determine what's the damage level. So that's how we come up with that building damage level of 5, 4, of build damage level of 2. It's exactly based on this assessment. So in terms of the building retrofit, what happens is that once we do let's say that we fail on the P&I and we need to really proper look into how this building will stand, we can do a fine element analysis to determine what is the impact, and you can see the stress points on this building, which one is going to be the highest stress points based on that overpressure that we calculate. With that in hand, we get to the next stage, which will be, okay, we can retrofit a building, which could be just in a regular putting a shower on the building, or it can be a full-blown retrofit of the building. All of this is going to be options that we're going to be discussing, and there's going to be discussed with the clients and so far on in terms of what is accepted, what is not accepted. But this is one option. And we can do the same assessment not only for that, but also for structures around. So not only buildings, but structures can also be doing the same approach that we did here. So the main idea of this webinar was to actually show that we can cover every stage with you guys. If you're gonna do a facility signing you should look for someone that can provide you the whole spectrum of things, and not someone that's just gonna provide you with the overpressures and radiations, and then you need to look for another person that can do that. So we help you guys throughout the whole process with a seamless and thorough analysis of everything we do. I have been doing consequence modeling facility signing for over 25 years. Some of the guys over here done is for even longer than I do. So we have a strong and very knowledgeable team on that. We have this innovative hybrid methodology that focuses on the CFD application. This tailored approach actually reduce the overly conservative results and actually lead us to more actionable outcomes and actually get more appropriate answers to your questions. We're only going to utilize the CFD approach on the key scenarios. We try to minimize the reliance on risk-based scenarios, because first, the company will need to have a criteria associated to accept the risk, and if not, it becomes a little bit of an issue. And again, this is a cost effective without compromising the cost and without compromising your results. So, and then that basically is the intention and what I had to provide to you guys. I'll open the room for questions. So, Mark, if you can lead that, I'll be happy to help.
Excellent. Great work. Thanks, Vinny. Now, once again, if you have questions, please add them to the questions section on the right hand of the screen, and we can get you an answer. One of the questions that have come in for us, Vinny, is will the return always be in the 2 orders of magnitude?
That's an excellent question. Not necessarily. This will depend on your situation. This was one study that we managed to do quite a significant reduction. We have done things that will do cost dropping half. So it will depend on what really is your threshold and how much the CFD would help your assessment.
Perfect. Thanks, Vinny. One other one that we have here is what is different on the CFD model for the hybrid approach when compared to a CFD study?
Okay, so the way that we do this to not affect cost or anything, we take advantage of the CFD by doing the big obstacles. We do not do the small bore piping. We don't do the small flanges, the small. All we do is, if you have a 3D model of your plant, great, that's all we're gonna use. If you don't, all we're gonna do is build blocks, cylinders, and just do the big interaction. So of course, if we're gonna do this as a full-blown CFD assessment, even with the explosion, then we're gonna need the small bores and do some porosity or something like this. But at the moment, that initial assessment that we do, we just use the big piece of equipment. So it's basically the big cylinders, the big pipes, the big tanks, the big heat exchangers, and that's all gonna be represented by blocks and different structures.
Perfect. Thank you. Another one here is, can my company do a risk-based facility siting if we do not have a risk acceptance criteria defined?
That's a complicated situation. We can do based on generic other countries' regulations and so far on. So, for example, if you are going and doing things in the UK, you have the HSE that defines. Australia has their own criteria. Brazil has their own criteria for thresholds of risk acceptance. If you were working, for example, in the US and your plants in the US, that becomes a little bit more of a complication, because it's, except for some specific counties, like in California, we have counties that have risk assessment requirements, but most of them don't. Then it's something that it cannot be just, it's a complicated situation because we can plot against different criterias, but it's something that the company needs to accept. So it's more like a higher hierarchy kind of definition in there. But we can do the assessment with a risk base, but we can't really do it anymore.
All right. Thanks, Vinny. Another question here is, do you guys carry out explosive chemical modeling? That they have a process with nitration compounds in one of their capital projects?
So it can be done by calculating what will be the outcome of that nitration product. And if that product in the end is an explosive, we can do the explosion modeling with that component.
All right. Another question here is, if the consequence is high, but the risk is within an acceptable range, what will be your recommendation in that context?
So the consequence is high, but if it's within your acceptance of risk, we are okay to accept. Our recommendation is gonna be that you match your criteria, because once you move to the approach of doing a risk assessment, then you're accepting a risk, and then we need to look into acceptable range more than anything else. So if it's within the LR, again, as low as reasonable practicable, we can make recommendations still to reduce the severity, but we're gonna say that you are within an acceptable range.
All right. Thanks, Vinny. Well, it looks like those are the questions. Hearing no others, we will certainly want to thank you for joining us for our discussion today covering facility siding. Should you need any assistance with testing and process safety support, please feel free to contact us. Here in the US, you can contact us at info-us@sigma-hse.com. We look forward to being a resource to you, and thanks again for joining us.